हेलो माय डियर मैकेनिकल चैंपियंस, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? क्या हाल चाल? आई होप एवरीवन इज सेफ एंड साउंड एंड डूइंग योर प्रिपरेशन विद योर फुल डेडिकेशन, हार्ड वर्क एंड enthusiasm. Guys, this is Chandra Shekhar welcoming you all to the India's largest, best and your favorite live learning platform, that is Byjus Exam Prep. कैसे हैं सब लोग? Please do let me know through the comment section, those who are watching me live, so that we can start the session as early as possible. Hi Piyush, good evening, welcome. What's up? How is your preparation going on? As you can see, this session is the part of the free course on GATE Rankers Monsoon series, which is running on Byjus YouTube channel for all the engineering aspirants, GATE 2023 aspirants who are preparing for the examination. So we are here to help you out to achieve your desired objective through this free series. So in this series, this is the series for heat transfer. We are going to discuss the important topics or the important, very good question, wonderful question from the various topics of heat transfer, and through the question practice, we are going to discuss the related concept. So it is very important for you guys to keep your pen, notebook and calculator. मैं बहुत बढ़िया. Hi Vikas, good evening, welcome guys. Please do share the link of this session to all your friends so that more and more people can join and we can have better understanding, better learning of the subject heat transfer. आज हम बात करने वाले हैं स्टडी स्टेट कंडक्शन. What is steady state conduction? Can you just let me know what exactly is steady state conduction? The conduction is studied in two parts. One is the steady state conduction, another is the unsteady state conduction. What is the difference between these two? Anyone having any idea what is the difference between steady state and unsteady state conduction? The steady state conduction cover most of the conduction syllabus. Around 60 to 70% of your question paper, heat transfer question paper, will contain the questions from the steady state conduction. So the weightage of steady state conduction is around 60 to 70%. Remaining all topics will cover the rest of the topics. That is the importance of the topic steady state conduction, and the topic is very simple, very easy to understand and very easy to score the maximum marks in your GATE examination. Cannot skip this topic if you are sincerely preparing for your GATE 2023 examination. विकास ने सही कहा, study means independent of time. When the temperature is not a function of time, then the system is said to be in steady state. Then the system is having the conduction to be in steady state. Can you just let me know the situation when we assume the system to attain the steady state? What is the practical situation when the system can achieve the steady state? बताइए, anybody? So before everyone else join, let me quickly introduce myself so that more and more people can join, and then we will start our session. My name is Chandra Shekhar. I have already told you I am having more than 10 years of teaching experience in GATE, IES and PSU. Mechanical engineering graduate from IIT Delhi, cleared engineering services examination, worked in SAIL for a couple of years, and I am quite comfortable in these many subjects of mechanical engineering, and heat transfer is one of them. If anybody is having any doubt during the session, after the session, before the session, you can always contact me through the mail ID which is there on the screen. That is chandra.shekhar@byjusexamprep.com, and I would recommend you guys all to join me on the Telegram. Once you become part of my Telegram group, you will be getting all the exam notifications every now and then. Whenever we will be having any notification for any of the exams, I will let you know through the Telegram. After the session, you will get PDF of all the classes, and study notes will also be provided to you, and all the free sessions updates information will also be provided to you, and I am also giving you the questions every now and then for solving, for getting your concepts clear. The more you practice the numericals, the more comfortable you become. When a system is kept in a particular environment for longer period, yes, BYJU'S, very nice. When we keep a system in a particular environment, then the system will attain the temperature of the environment, and the temperature of the system will no longer be a function of time. This is my link for joining the Telegram group. Those who are not part of this Telegram group, I would request everyone to join me on the Telegram and share your knowledge and keep improving yourself. So this session is the part of the GATE Rankers Monsoon series. If you are unable to join these free sessions, you can just subscribe our Byjus YouTube channel. The link is also given in the description box for all our Telegram groups as well as our YouTube group. Alright, so do subscribe Byjus YouTube channel, and then you will be able to get all the updates for all the free classes, free sessions, free courses which we bring from time to time. Yes, very nice. So are you all ready? Keep your pen, paper and calculator handy and do solve the question. There is the first question on the screen. I want everyone to solve this. And please do share the link of this class to everyone else in your friend circle. Because the strength of the students is very less. When the students are not as per the requirement, then it is not very fruitful to have this session more lively, more energetic. So this is my humble request to every one of you to share the link of this class to all your friends, all the other Telegram groups you are part of, so that it reaches to maximum students and everyone gets benefited. The first question on the screen, can you guys just solve the question? Can you solve it? A wall of a furnace is made up of inside layer of silica brick, which is 100 mm thick. Silica, which is 100 mm thick, is covered with a layer of clay brick of 50 mm thick. There is a clay. This is clay. This is 50 mm thick. The inside temperature of the silica brick wall is 725 degrees Celsius. This is 725 degrees Celsius. And outside surface of clay brick wall is 100 degrees Celsius. This temperature is 100 degrees Celsius. So it is composite system. We can call it as composite system. And one more information is there. If the contact thermal resistance is significant, most of the questions you may find the thermal contact resistance to be negligible. In most of the situation, in most of the 99% of the questions, you may find the contact resistance to be insignificant. But here you need to consider the contact thermal resistance. Why does it happen? Where do we have the contact resistance? When the surface which we are joining are not smooth. If the joining surfaces are not smooth, then between the gaps the air is trapped, and air is an insulator. Air is a thermal insulator. That is why it reduces the rate of heat transfer. That acts as a thermal resistance, the heat flow. So the joining between silica and clay is not perfectly smooth, and that is why the thermal contact resistance or contact thermal resistance is getting developed. What is the temperature drop at this interface? The question is to find out delta T for this interface. There is a temperature drop at the interface also. Can you solve the question? Yes, the gap is there. So what we can say, if we draw the circuit diagram, the heat will flow from left to right. Q will remain constant. Q will remain constant. If we draw the circuit diagram, how many thermal resistances will be drawn? Very nice, Shubham. Well done. Can anybody also let me know the answer? If you draw the circuit diagram, then there will be 3 thermal resistances in series. This is R1, that is L1 by K1A. This is R3, contact thermal resistance. And this is R2, that is L2 by K2 into A. The thermal conductivity of silica is given. The thermal conductivity of clay is given. Area will remain constant. Area which is normal to the direction of heat flow will remain constant. This is 725 and this is 100 degrees Celsius. So we can say Q is equal to delta T over all upon R equivalent. And if we want to write Q dash, then it will be 725 minus 100 divided by 1 by A, or we can write it as R1 plus R, this is 2 only. We can say RC plus R2. Q is given, Q by A is given. So Q is equal to, if you put the values, can you solve it? Are you guys getting option A or not? If you solve this, then you can say Q dash is given as 5 kilowatt. So 5 into 10 to the power 3 into area is equal to 625 divided by L1 by K. What is L1? 100 mm. 100 mm, that is 0.1 upon K1. The thermal conductivity of silica is 1.7 into area plus RC plus 50 mm 0.05 upon thermal conductivity is 5.8 watt per meter. From here you can find out the value of RC. What is RC? That will be equal to 625. Find out the value of RC. 625 divided by 5 into 10 to the power 3A minus 0.1 upon 1.7 into minus 0.58. 0.05 upon 5.88. From here you will get RC. What is the value of RC you will be getting? So RC will be equal to 1 by A multiplied by, your answer should be coming out to be, or A into RC, you can write A into RC. That is called as unit thermal resistance. A multiplied by RC will be equal to 125 minus 58.8 minus 8.6 into 10 to the power minus. That will be, the unit will be meter square Kelvin per unit. And Q dash is equal to delta T for the interface upon A into RC. If you put the value, then we can find out delta T interface. If you are not committing any calculation mistake, then your answer will come out to be 287.9. 287.9 degrees Celsius. Are you getting 287.9 or not? The correct answer is option A. Is there any other method? Shortcut? Is there any other shortcut for getting your answer? The answer will be 287.78 something. The nearest option will be treated correct. Alright. The next question, common data for second and third question. The next one is common data. Read the question and try to get your answer. A wall which is 300 mm thick. The thickness is 300 mm. Is made up of two layers A and B, which is shown in the figure. The temperature is shown in the sketch. The inside temperature is 1325. Intermediate temperature is 1200 and it is 25. The ratio of thermal conductivity of the two layers is 2. Find the ratio of thickness of two layers. LA by LB will be how much? The thickness. The ratio of thickness of two layers. What is the answer? What is the answer? We can say Q is equal to Ka delta T by L, which remains constant. The heat transfer rate will be constant. Very nice, Bhavya, Sachin, Piyush, good. Shubham, well done guys. What is the answer to this one? Question number 2. Q is constant and area is also constant. The area which is normal to the direction of conduction is constant. If area is constant, Q is constant. So we can say L is proportional to K into delta T. That is the relation. And LA by LB will be equal to Ka by Kb into delta TA by delta T. That will give you the answer. If you put the values, Ka by Kb is 2 multiplied by what is delta Ta? 1325 minus 1200. 1325 minus 1200. That is the numerator. And what is delta Tb? That is 1200 minus 25. That will give the value of the ratio between the thicknesses of two layers. What is the answer? What is the correct answer? Are you guys getting option A or not? Yes. Are you guys getting option A? 0.213. Hi Rashad, how are you? Good to see you after a long time. Correct answer is option A. The next part of the question, third, what is the thickness of layer A? The next is what is LA? What is LA? So do you agree LA plus LB is equal to 300 mm? And LB can be written as we have already calculated. LA by LB is 0.213. What is LB? So we can say LA plus LA upon 0.213 is equal to 300 mm. LA 1 plus 1 upon 0.213 is equal to 300 mm. We can easily find out the value. We can find out the value of LA. What is the value of LA? Question number 3. Are you able to get the answer? Is it 52.6 mm? Very, very nice. Good, 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 good. Once you are able to get the correct answer for part 1 or second question, then only you will be able to get the correct answer for the next part. Option A is the correct answer. Right? 52.63. Question number 4 on the screen. The next one, Sachin, well done. Rashad, well done. Piyush, good, good. What about question number 4? A concrete slab of basement is 11 meter long, 4 meter wide, and 0.2 meter thick. The thickness is very, very small compared to the length and the width. That is why the conduction is taking place along the thickness, the height or the thickness. During the winter, temperature at the top is 17 and the bottom is 12 degrees Celsius. If I draw the wall of the basement, then it is, let us say, like this is how the wall. This is the thickness or height, this is the length, and this is the width. This is 17 and this is 12 degrees Celsius. So the conduction is taking place from top to bottom. That is Q, which will remain constant. That is the direction of conduction from top to bottom. The concrete has a thermal conductivity of 1.5 and the basement is heated by the gas furnace operating at efficiency of 0.8 and the gas is priced at this. What is the daily cost of heat loss? What is the daily cost of heat loss? The heat loss is taking place from top to bottom. If we want to find out Q, that is Ka delta T by L. Hi Subhadeep, good evening, welcome. Welcome to the session. K delta T by L. Put the values. K is the thermal conductivity is 1.5. What is the area? A is the area which is perpendicular to the direction of heat flow. That is L into B. That is 11 into 4. And what is delta T? 17 minus 12. 17 minus 12 upon H. Let me write H. It is the thickness, that is H, which is 0.2. From here we can find out the value of Q. That is the heat loss per second. Q is nothing but the heat loss from the basement per second. What is the value of Q you will be getting? Is it 1650 joule per second? That is the heat loss per second. And what is the amount of heat loss daily? Or this is the heat loss from the basement. And if I ask you what is the heat required by the furnace, heat required by furnace will be is equal to 1650 divided by 0.8 because it is working at an efficiency of 0.8, that is joule per second. Heat required by the furnace is equal to 1650 by 0.8 joule per second. So daily heat required daily means every day, that is 1650 by 0.8 into second should be replaced by the hour. It will be 36 into 24, isn't it? That is the joule. That will be the joule, isn't it? That is the heat required daily. And because gas is priced at ₹1 per megajoule, so for 1 megajoule, that is equal to 10 to the power 6 joule, the cost will be equal to ₹1. Cost will be ₹1. For 1 joule, it will be 1 by 10 to the power 6. And for this much joule, so we can say the total daily cost will be equal to 1 upon 10 to the power 6 into 1650 by 0.8 to 3600 into. That will give you the answer. That will. Isn't it? What is the answer? Are you getting 178.2? Rupees 178.2. The total daily cost will be rupees 178.2. Option A will be the right answer. Yes. Yes, Rashad, 178.2. Sachin, well done. Bhavya, Vikas. Next question, question number 5 to 8 is again common data question. A temperature distribution across a wall 1 meter thick at a certain instant of time is given by this expression. Parabola. It is a parabola where A, B and C are given. A uniform heat generation is given in the wall of area 10 meter square having the properties. Determine the rate of heat transfer. If we draw this parabola, then the parabola will be looking. This is the temperature profile. This will be the temperature profile. If we find out dt by dx, that is equal to B plus 2Cx, it will be negative and increasing in magnitude. Dt by dx is negative and increasing. The slope is negative and increasing in magnitude. This will be the curve drawn. And why the temperature profile is parabolic? There are two situations because of which the temperature profile can be parabolic. One is because of variable thermal conductivity, but here the thermal conductivity is given constant. Another situation where the profile becomes parabolic is due to heat generation. So there is a heat generation. So the heat will flow from the temperature profile. You can see the heat will flow from left and will leave from the right. This is x is equal to 0. This is the direction of heat transfer will be from left to right. The question is determine the rate of and the mode of heat transfer will be conduction. Determine the rate of heat transfer entering the wall. The heat is entering into the wall from x is equal to 0. So you need to find out Q at x is equal to 0, that is minus K into area into dt by dx at x is equal to 0. What is the value of dt by dx at x is equal to 0? That is B. Put the value minus K, that is minus 40. What will be the area? Area is equal to 10 meter square into dt by dx, that is minus that is B is equal to minus 30, minus 300. That will give you the rate of heat entering into the wall. The correct answer is option A. Is the right answer. The second part is determine the rate of heat transfer leaving the wall. The heat is leaving from the wall at x is equal to 1 meter. Q out will be equal to Q at x is equal to 1 meter. that is equal to minus k into a into dt by dx at x is equal to 1 meter. The value minus 40 into 10. And what is dt by dx at x is equal to 1? dt by dx is equal to b plus 2cx. That is equal to b plus 2cx. Put the value of b, c. It will be minus. Can you do the calculation? B is equal to minus 300 plus 2 into c. C is equal to minus 50 into x. That will give you the value. What? Q out will come out to be 160 kilowatt. Are you getting it? The answer is option B. For this, the answer will be option B. Question number 7 is determine the rate of change of energy storage in the wall. The heat is entering from x is equal to 0. The heat is leaving from x is equal to 1 meter. Q in is equal to 120 kilowatt. Q out is equal to 160 kilowatt. If we apply the energy equation for a system, Q in plus Q generated is equal to Q out plus Q stored. That is the rate of change of energy storage. Q in is 120 plus what is the value of Q generation? Q dot into volume. The rate of uniform heat generation is 1000. It will be 1000 into 10. That will be what? We want it to be in kilowatt. So it will be 10 kilowatt plus 1 into 10. That is the volume. Is equal to Q out is 160 plus Q. What is the answer? Yes, Rashad. So what is Q stored? Are you getting minus 30 kilowatt? Rate of change of energy storage or rate of change of internal energy of the system is minus 30 kilowatt. Because it is negative, it means the temperature decreases with the time. The temperature decreases with time, or there is a cooling of the system taking place. Because of negative heat storage, there is the cooling of the system. The next question, question number 8. Determine the time rate of temperature change at x is equal to 0.25. That I want you guys to solve. Give me the answer for this one. Because the temperature decreases with time. Temperature decreases with time. So dt by dt will be negative. It will be negative. So C cannot be correct answer. C cannot be right answer. It cannot be positive. The rate of change of temperature with the time will not be negative. What is the answer to this one? At a particular location, that is x is equal to 0.25 meter, we need to find out the value of dt by dt. dt by dt is required at x is equal to 0. Can you solve it? Vikas is saying option D. What about others? You can start with the governing differential equation that says d square t by dx square plus q dot by k is equal to 1 upon alpha dt by dt. That is how temperature is a function of x and tau. At a particular x, we can find out dt by dt. At a particular location, we can find out dt by dt. If you calculate d square t by dx square, if you find out d square t by dx square, dt by dx was calculated as p plus 2cx, and d square t by dx square will become b, isn't it? Sorry, it is 2c, will become 2c, which is not a function of x. So d square t by dx square is not a function of x. What does that mean? It means dt by dt will be same for all x. dt by dt will remain constant for all the value of x. Are you understanding it? Because d square t by dx square is not a function of x. That is why dt by dτ will not be a function of x. It will be same for all value of x. How to find out? Because we have calculated Q stored, that is equal to minus 30 kilowatt into 10 to the power 3. That can be calculated as m dot Cp. What is Q stored? That is equal to mass flow rate into Cp into dt by dτ. You can find out from here. What is the mass flow rate? That is density into volume. Mass flow rate is density into volume. Density is 1600 into volume is 10 into 1. Volume is 10 into 1 into dt by dτ. Solve this, then you will get the answer. For all the value of x, dt by dτ will remain constant. The correct answer is option A. You must get around minus 4.69 into 10 to the power minus 4 degrees Celsius per second. Minus 4.69 into 10 to the power minus 4. Right? A will be the answer. Next question. Common data for 9, 10, 11 questions. In this figure also, the steady state temperature distribution in a composite plane wall. There are three materials A, B and C. There are three materials A and B. Each of constant thermal conductivity is shown. The thermal conductivity of A is Ka. Thermal conductivity is constant. And the temperature profile is also constant for A and B. It means in A and B, there is neither any heat generation nor any heat. It is the steady state. It means there is no heat stored. But in A and B, Q generation will also be equal to 0. But if we talk about C, the temperature profile will be a parabola. So in C, there is a heat generation. In material C, there is a heat generation. That is why the temperature profile is parabola. Are you getting it? I told you there are two situations where the temperature profile become non-linear. One is the variable thermal conductivity, which is not the case because constant thermal conductivity is mentioned for all the materials. The second possibility is when there is a heat generation in the steady state system. That is why the temperature profile will be non-linear. In C material, there is a heat generation. And the heat is always flow from high temperature to low temperature. So the direction of heat flow will be from right to left in negative x direction. Negative x direction. Now let us talk about the question. Q2 dash is this. Q3 and Q4 dash are given as the heat. The first part of the question is which is correct about relative magnitude of interfacial heat flux. What is the relation between Q2 double dash, Q3 double dash and Q4 double dash? The first part is develop the relation which of the following option is correct for Q2 double dash, Q3 double dash and Q4 double dash. Because in material A and B, there is neither any heat generation nor any heat storage. So for A and B, can we say Q in is equal to Q out? Because Q stored is equal to 0 because the system is in steady state and Q generation is equal to 0. So the heat entering Q3 double dash and heat leaving. So the rate of heat transfer in A and B, QA is equal to QB remains constant. Do you understand it? That means Q double dash is equal to Q. A and C cannot be correct. A and C cannot be correct. What about B and D? So now we need to develop a relation with Q4 double dash. Now try to understand for the interface 3, if we talk about the energy balance equation, so we can say whatever the heat entering into the interface 3, let me call it as Q3. So Q3 is equal to Q3 double dash, isn't it? At the interface, whatever the heat entering will be equal to heat leaving. And Q3 can be written as, what is Q3? That let me call it as X is equal to 0. This is X is equal to minus 1. This is X is equal to minus 2. Let me call it as X So Q3 is equal to Q3 double dash is equal to minus K, thermal conductivity of material C. Q3 can be written as thermal conductivity of material C into A into dt by dx in material C at x is equal to minus 1. That will be Q3. And if we talk about Q4 double dash or between Q3 and Q4, if you see, so Q3 is proportional to, or QC is proportional to dt by dx. Do you agree? There was no need to. Now, try to understand. If we observe the material C, so Q in C is equal to minus Kc into A into dt by dx in the material C, isn't it? Thermal conductivity in material C is constant, area is constant. So we can say QC is proportional to dt by dx in material. And Q3 is also in material C and Q4 double dash is also in material C. So we can say dt by dx at x is equal to minus 1 is greater than dt by dx at x is equal to. What we can say from here, Q3 will be greater than Q4 double dash. Do you agree? Q3 is greater than Q4 double dash. Q3 is greater than, and this Q3 is equal to Q3 double dash is equal to Q. Are you able to understand it? In material C, Q is proportional to dt by dx. dt by dx is variable. The temperature gradient or the slope of temperature profile is variable, because the temperature profile is non-linear. That is why, and there are 2 points in material 3. One is material C, one is point 3, another is point 4. At point 3, that is Q3, will depend on dt by dx at x is equal to minus 1, and Q4 double dash will depend on x is equal to dt by dx at x is equal to 0. So you can see that slope at 4 point is less compared to the slope at point 3. That is why Q3 is more than Q4 double dash. Option B is the correct answer. Option B. No, Bhavya, we cannot say that. Why? Because there must be some heat entering from here also. अच्छा, आप बोल रहे हैं Q4 double dash. This is Q4 double dash. So heat entering. So Q4 double dash. What we can write? Yes, that is correct. Q3 double dash is equal to, yes, definitely we can write this. What we can say? Yes, definitely. What we can say from here? That Q3, if we apply the energy conservation equation for material C, energy equation, if we apply energy equation for C, then we can say, and heat entering is Q4 double dash, plus there is a heat generation in the material C is equal to Q3 double dash, that is heat leaving, because heat stored is equal to 0. Q stored will be equal to. This is how we can say. Definitely we can say Q3. That is another approach. Yes. Q3 double dash is greater than Q4. Very nice, Bhavya. Yes, definitely we can write this. The next part of the question, which is correct about the relative magnitude of thermal conductivities. For material A and B, Q is constant. For A and B, Q in is equal to Q out. That remains constant. So we can say thermal conductivity is inversely proportional to dt by dx, isn't it? For material A and B, but we can say Q in is equal to Q out is equal to, or we can write QA is equal to QB. Whatever the heat traveling in material A is equal to heat traveling in material B. Q in is equal to Q out, that is constant, that is equal to minus K into A into dt by dx. So Q is, thermal conductivity is inversely proportional to by dx. Thermal conductivity will be inversely proportional to dt by dx. So the slope of dt by dx for A is greater than dt by dx for B, isn't it? dt by dx in material A is greater than dt by dx for material B. That is the slope of the temperature profile. Slope is tan theta. This angle is more compared to this angle. Slope is more in A. Thermal conductivity of A is less than thermal conductivity of B. A is less than B. A is correct. A is correct. And what about B and C? If we talk about B and C, we can have this to be Q3. Q3 is Q3. Is Q3. Okay, we can say Q3 is equal to Q3 double dash. That is constant. So here also K is inversely proportional to dt by dx. Is inversely. We are considering this interface. So the slope, if you see, this is angle theta. Tan theta is the slope. And if you see the slope of this, it is having more. This is having more. So Q3, so dt by dx at 3 will be greater than dt by dx at double dash. dt by dx at 3 is greater than dt by dx at 3 double dash. Then we can say K3. What is K3 double dash? That is KB will be less than sorry 3 double dash is more na. The slope of 3 is more than 3. 3 is means Kc. That is Kc, thermal conductivity in material C. 3 is in material C and 3 double dash is will be Kc is less than K. Isn't it? So thermal conductivity of material C is less than. The correct answer is option C. So the relation is Kb is greater than Ka and Kb is greater than Kc. That is the correct relation between the thermal conductivity, right? Kb is, yes, the slope is more for C compared to the B. The correct answer is option C. Both A and B are true. Both A and B are correct. Now it is your turn. What is the heat flux distribution as a function of X? Now, can you guys let me know the distribution of heat flux? Heat flux distribution as a function of X. The temperature profile is how the temperature profile is. Which is the correct answer for the variation of heat transfer rate in X direction? This is X is equal to 0. Let us say this is X is equal to minus 1, equal to minus 2, X is equal to minus 3. In material A and B, Q remains constant. Q is equal to constant. So QA is equal to QB. In material A and B, Q will remain constant. So this cannot be true. This is material A, this is material B. Material A, B is A, B, C. A. Third and fourth cannot be true because in material A and B, the rate of heat transfer will remain constant. And in the material C, the rate of heat transfer will be variable because Q is equal to D by D. More is the temperature gradient, more will be the rate of heat transfer. The heat transfer rate is more at x is equal to -1, and then the heat transfer rate will almost 0 at x is, because it is a parabola. Q as a function of x is parabola, so dt by dx is function of x, which isn't it? dt by dx, or temperature as a function of x is. Temperature profile is parabola if t is a function of x is parabolic, and the differentiation of t with x will be a linear. That is why Q will be a linear function. It will be a linear function. Cannot, option B cannot be correct. Option A will be the clear. Option A will be. Next question, question number 12. The next one. Find out the answer to the next question. A heat exchange through a furnace wall of a boiler was observed to be 20 kilowatt per meter square through convection. Q convection is equal to per meter square, and 50% more than this through radiation. So Q radiation is equal to 1.5 times 20, that is 30 kilowatt per meter square. So there is a combined mode of heat transfer. What is the total rate of heat transfer? That is equal to Q convection plus Q radiation. That is equal to 30 plus 20, 50 kilowatt per meter square. The thermal conductance of the wall is 60 watt per meter square Kelvin. What is thermal conductance? Unit will tell you. The thermal resistance is having the unit Kelvin per unit watt. Area multiplied by thermal resistance is called as unit thermal resistance. It is called as unit thermal resistance. The unit is given by meter square Kelvin per unit watt, and the reciprocal of this is called as thermal conductance, watt per meter square Kelvin. Isn't it? So it is 1 upon A into RTH is given, that is 60 watt per meter square Kelvin. Do you agree? That is known as unit thermal conductance. You can call it as unit thermal conductance. The reciprocal of resistance, thermal resistance, is conductance. But because meter square is also used, so it is multiplied with area. If the inside surface temperature of the wall is 1000 and the external surface temperature is, this is 1000, need to find out T. T1 is given as 1000 degrees Celsius. Find out. Can you do this? So Q will be equal to K into A into delta T upon L. Isn't it? And the rate of heat transfer is 50. So we can say Q by A, that is equal to 50 into 10 to the power 3 is equal to K delta T by L. And that is equated with delta T upon A into RTH. Isn't it? What we can do is, what we can do from here is, what we can write, don't use this. If we use the other expression, what is that? We use Q is equal to delta T upon thermal resistance. We can say Q by area, that is equal to delta T upon A RTH. And 1 upon A into RTH is given as 60 watt per meter square Kelvin, and Q by A is as 50 into 10 to the power 3 is equal to 60 into 1000 minus T. Will give you the value of T. What is the answer for T2? Value of T2 will come out to be 167 degrees Celsius. Isn't it? It is 167 degrees Celsius. One more question, the last question for the day, and tomorrow we will be back with the unsteady state conduction and fin theory. I will bring some numericals from the another topic of conduction, that is the fin theory and unsteady state conduction. At critical insulation radius for cylinder or sphere, what is the correct answer? At RCR, the total thermal resistance is maximum. Is it true or false? A is false. That thermal resistance is not maximum, up to which heat flow rate increases and after that it start decreases. If we draw the curve for rate of heat transfer, that is Q without insulation Q, and this is, let us say, RCR, that is R naught. As R increases, becomes maximum and then it start decreasing. B is correct. Total thermal resistance, if we draw the curve for thermal resistance versus R, then this is minimum. The thermal resistance minimum at RC. The thermal resistance is minimum because Q is inversely proportional to thermal resistance. So when thermal resistance is minimum, then the heat transfer rate is maximum. The total thermal resistance is minimum. So B and C both are correct. So the correct answer is option D. The right answer is option D. Both B and C. Alright, so that is all from my side for this session. I hope you guys have enjoyed it and understood the concept, how the formula for conduction can be used for analyzing the numericals related to this. Tomorrow at the same time at 6 p.m. I will be there with some wonderful question from the unsteady state conduction and fin theory. These two topics are very much interrelated to each other. In the analysis, as per the analysis point of view, these two topics are interrelated with each other. So I want you guys to revise the concept of these two topics before coming to the next class. And this is my entire heat transfer schedule. You can take the screenshot and be there every day at 6 p.m. For the whole week, I will be there with you. And on Sunday, I will take a practice session or I will take a quiz for all the topics of heat transfer. That is all from my side. And again, I would remind you to join me on the Telegram if you have not joined me yet, or you can always contact me through the mail ID. With this note, let me take your leave. Stay safe, stay motivated, and keep preparing with full dedication and hard work. If you have anything to ask, you can always ask me through the Telegram, or you can write me the mail, or you can write in the comment section also. Anything. I will share the PDF of this session also to my Telegram group. Stay tuned. See you tomorrow. Thank you and